Hey everyone, in this session, we will discuss about scalability of system design. Scalability ensures a software system can accommodate growing users without experiencing any major bottlenecks or failures. Let's understand it with an example. Let's assume you have a server for your application and you are getting 100 requests per day because initially user base of your system will be less. In this situation, your server is capable enough to respond back to all 100 requests within predefined SLA or as per service level agreement. However, assume over the period of time your application is famous. Then what will happen? Your user base will grow drastically. Now assume if you are getting 1 million requests per hour, your existing server will fail. Your existing server does not have enough infrastructure to handle 1 million requests per hour. That means we need a better equipped server to handle 1 million requests per hour. We have to enhance the infrastructure to handle 1 million requests per hour. To handle this situation, we need to scale the system for this grown up user base. Just a side note, we always estimate the number of requests in 1K or 1M or 1B, where 1K is 1000 requests, 1M means 1 million requests, which is nothing but 1000K, 1 billion is 1000 million. I know most of you are aware about this calculation, but I just wanted to keep it here so that you can brush up this. It will help during your interviews or during the estimation of your server load. Now let's understand how we can perform scaling. Either in the same single server, we can enhance the configuration. By configuration, I mean the CPUs and the memory. We can increase them in order to handle more requests, or we can have multiple servers with standard configurations, and we can distribute the requests among multiple servers. These two different approaches we have while scaling up the system. The first one is known as vertical scaling. The later one is known as horizontal scaling. Let's understand vertical scaling and horizontal scaling in detail. In vertical scaling, we keep the same server, we increase the memory and computes, but it has single point of failure. If your server breaks down due to some reason, the whole application will be down and no user will be served during the downtime. One more problem with vertical scaling is whenever there is less number of requests, you will be underutilizing the capability of your server. Remember, the number of requests vary a lot throughout the day and in turn throughout the year. Sometimes there will be spikes, means you will get more number of requests to serve, and there will be some lean period when you will get very less requests in your server. In case of vertical scaling, as you already have incurred the cost to increase the compute and memory, it will be underutilized during lean periods, and cost optimization is not possible here. Let's check out horizontal scaling now. In case of horizontal scaling, as we have discussed, there will be multiple servers with standard configurations. Now, there will be a overhead to distribute requests between multiple servers. Request processing time will have overhead to choose the specific server. However, the good part for horizontal scaling is we can scale down during lean period. That means we can reduce the number of servers during lean period. We can optimize the cost efficiently. Furthermore, it does not have single point of failure, because even if one server is down, we can distribute the request between n-1 number of servers. Hope you have realized the difference between vertical scaling and horizontal scaling. Let's now understand how to analyze the system to understand if scaling is needed. We need to gather performance matrices for our application in order to analyze our system. Three main matrices what we should know. Response time is the time for a system to respond to a user's request. That means when your server is getting a single user's request, how long it is taking to respond back. Usually it is measured in milliseconds. However, in some situations we measure it in seconds or in microseconds as well. Throughput is the rate at which system processes the requests. Usually it is in requests per second or RPS or transactions per second or TPS. That means total number of requests server can handle in a second. That is known as throughput. Apart from response time and throughput, we also check resource utilization. In other words, we check CPU, memory and storage utilization. Usually, these are all measured in percentages. Let's understand how can we evaluate them and optimize them as much as possible. For that, we do benchmarking and profiling of our software system. Benchmarking gives us the overall system performance, whereas profiling is a process of evaluating performance of each component. Usually, we perform profiling during the development phase itself. Profiling is mainly used to identify the bottlenecks in our system. There are a number of tools available to perform profiling of your system. A very common is IntelliJ built-in profiler. If we want to check the memory utilization, if there is any memory leak in your system, Visual VM is the one through which we can do all those analysis. Similarly, for benchmarking, JMeter is a very popular tool where we can simulate multiple requests and check how our software system is behaving when there are a number of concurrent multiple requests to serve. Hope you have realized what are the performance matrices related to scaling. Based on these performance matrices, we will be able to understand that if we need to scale out or scale up our system or not, because we will have in-depth information that how much a single request will take to process in our server. What will be the threshold of CPU and memory utilization? And even using JMeter, we can perform the load test. We can simulate 1 million users request and we can analyze the system performance accordingly. These are all very important for our scaling decisions. Remember, our software system degrades its performance when we have a number of concurrent requests to process. That is the reason it is very important for us to understand the maths to calculate concurrent requests. Let's assume a hypothetical situation when a system is experiencing 1 million requests per day. If we calculate 1 million by 86,400, on an average, we will be getting 12 requests per second. We have a very famous law called Little's law to calculate the average number of concurrent requests in a system. As per the Little's law, L equal to lambda into W, where W is response time in seconds and lambda is request arrival rate. Assume we are getting 12 requests per second and each request is taking 100 milliseconds to respond. Then, as per Little's law, in an average, there will be 2 concurrent requests in your system. Hope you have realized how can we calculate the number of concurrent requests in a system if we know the response time and total number of requests per day. Remember, average number of concurrent requests is a very important criteria for deciding scaling of a software system. Apart from these, we also check if our system is CPU intensive or memory intensive, because these will give us some idea to understand if we should increase the CPU of our system or should we increase the memory of our system. Monitoring resource utilization for a single request can be an identifier to decide if we will be using CPU intensive or memory intensive machines. With benchmarking, profiling, gathering performance matrices, understanding total number of concurrent requests what we may get in our system, and our system is CPU intensive or memory intensive. Based on these information, for a software engineer it will be very easy to decide on scaling of the system. Now let's understand how can we scale up or scale down our system. We can scale based on resource utilization of our system. For example, if the CPU utilization is more than 70% for last 5 minutes, we can scale out our system. Just a side note, usually in industry, scale up means you are increasing the infrastructure of your server. That means you are performing vertical scaling, whereas scale out means you are performing horizontal scaling. That means you are adding more servers so that total number of requests can be distributed into multiple servers. Similarly, if CPU utilization is less than 30% for the last 10 minutes, we can scale down our system, assuming that there is less number of requests we are receiving in our server. Apart from resource utilization based scaling, we can also set the scaling schedule based on the peak and off-peak hours. As an example, we can think of, we will be scaling down the system between 12 am IST to 5 am IST, assuming that people will be sleeping during this time and there will be less number of requests what our server will be serving. We can also evaluate some custom matrices, and based on the threshold value, we can either scale out or scale down our system. Hope you have realized how we can utilize few of the matrices to scale out or scale up or scale down our system. Nowadays, with public cloud offerings and containerization systems provides us ease to perform scale out and scale down activity very easily. We can set some rule, and based on those rules, it will perform auto scaling up or auto scale down. Let's understand the takeaways from this session. Now we know what is scalability of system design and why scalability is needed. We know what is vertical scaling and horizontal scaling and what is the basic difference between them. We realized few parameters based on which we will decide if we should scale up or scale down. We have seen the maths to calculate the concurrent requests of our system. Now we know how we can decide if our system is CPU intensive or memory intensive. These are all very important deciding factor for scalability. We know different ways through which we can scale up or down our systems. Hope you have enjoyed this session. Thanks a lot for watching this video.